Hey guys, welcome back to Anchor Designs. My name's James and today we are going to be working on a new project. It's going to be a new product for my good self and it's going to be, I don't know what to call it. I might call it the Anchor Square, although Anchor's not the best of name for multiple reasons. How often have you used a set square or a combination square and trying to scribe a line for either a mortise, or you're doing some tiling work, or you're doing some scribing work, and you try and use the square and you're moving along and then you try and slide in and it's bounding up and it doesn't work well. So I thought I'd make a square like this, and it's made out of aerospace stainless steel. It's a pretty good grade. It's rust proof. It's nice and hard as well. It's made out of 2mm. It's not bendy. It's nice and square. It's made on a very new laser machine, so the quality is pretty good. Although these ones in particular were a reject, so I got these for free, unfortunately, and I'll explain why later. So what we've got is nice and simple. The laser's done the hard work. For every 10mm, we've got a notch cut out. So this is going to allow you to use a pencil, use a scribe to mark down and then slide across. It hasn't got any graduations on this because I feel you don't need them, although I could put them on if I wanted to. So let's get started and I'll run through my ideas as we go on for the video. So the question is, why did these fail? Or why did these have an NCR? So when you use a fibre, a laser cutter uses effectively a bit of light, a bit of gas, a bit of software, a bit of programming, and you form that through a resonator straight down a fibre cable, and it allows you to convert light into power through a diode system typically. With this, you have what's called a splatter. So when you're cutting anything with a 2D thermal cutting source, you have to have the gas come through and then it's got to get rid of that material. And hopefully you can see this okay. For these holes, typically a general rule of thumb for most cutting applications was a 1-to-1 rule, which means if I wanted to cut a 2mm hole in material, the smallest you'd be able to do is 2mm thickness. So 2mm hole and a 2mm thickness, which is kind of what we've done here. But there has been some little bit of issues with the cutting, the program, the software. There's many variables, which to be honest is a bit above my head. So the general quality that I've got on here is quite a lot of splatter, and it's not very good. Whether that be consumable usage, gas pressure, I don't know, it could be the quality of the bed, could be the quality of the program. I wrote the program, so it's could well be, but it's not ideal. So what we're going to do today is I'm going to run through the idea behind this and the reason why I'm doing this, and we're going to go through the assembly. So I quite like the stainless look and I decided to go with brass rivets. So I bought some small brass rivets, and the size of these are 3mm by 8mm, which isn't quite big enough to get the desired look that I want. I haven't got enough material to be able to peen that over. So I bought what I thought was 3x10mm solid brass rivets, and the sent 2x10, which is definitely no good. So they're no good. I do have some aluminium rivets, which are slightly larger but are meant to be the same size. The supply is a bit strange and not the easiest to talk to. As well, the laser cutter cut it out the wrong material. I say wrong, but it should be just plain mild steel, and they decided to cut it on some 2mm DP1, which is a dull polished, so that gives you that sort of brush effect there, which is pretty nice. But these aren't handed, so these go like that. So you've got one side that's nice and polished, and then the other side that isn't, so not too happy about that. I want this to look good. You know, if you're putting your name on something, there's a degree of pride that we want this to have, and it's, you know, it's not the professional look. I like that dull sort of look, and there's a bit of a laser burn on the edge there. But anyhow, so what we're going to do is we've got some countersinking to do, and we've got to drill out the holes because the quality is not great, and we're going to have to try and clear these up as best as possible. Unfortunately, the time of year, Santa Claus is nearly coming to town, and the laser cutters are now closed, so I'm not going to get any parts until January, and I wanted to do this project before Christmas and make this video. So here we are. This is version 1. We might change things, and we're going to see how we go. Okay, so let's look at a comparison type. So this is your typical combination square. I've got a few Starrett ones and they're all in Imperial, but I'm using a metric one because my square is also in metric as well. It's just how I've designed it. I could make a Imperial one if I wanted to. So let's look at them. So this is for, as I say, for scribing, for layout, for marking out, etc, etc. It's meant to be nice, quick, easy, straightforward and accurate. What does the combination square? This is a awesome invention. It's probably one of my favourite tools that I use around my workshop, and it's an original Starrett design from Mr. Starrett himself. The history is fascinating if you want to go and have a look at it. So what do we typically use this for? So we can use it for depth, for miters, I've never used it as a spirit level. It has an inbuilt scribe. This design is pretty bomb proof, and that's why it's been around for, you know, nearly 150 years now. So why have I done this when you can have one of these? Well, I hope you can kind of work that out for yourself, really. Typically I use this in my everyday world for scribe lines. So if I would set that up to 30mm and put that up against an edge, scribe down there for either for a weld prep, or if I'm doing woodworking, I'd use it as for a mortising. And they're always sort of, the materials that we work with are always in a level of 10mm. So my idea was on here that we have segmented measurements for every 10mm. So from this point here, 10, 20, 30, 40, 50, etc, etc. So let's make a comparison now of this. So I'm hoping you can see that okay. But for every 10mm, we have a notch cut out in the anchor square, of which in the middle of that are meant to be these squares, diamond shapes, so you can square up a pencil or a knife edge or scribe marker to go in the middle. And then when we are scribing, we can put it in our notch, go down the edge of something, and then we've got this piece here. So if I grab a pencil, I can select 10, 20, 30mm. What you'd actually do it from this edge here, so 10, 20, 30, 40 if you wanted to. So 30, that's 30 from that point there. And then I can scribe down it, mark the X position, go up on the Y again if I wanted to, and I can select the thickness, etc, etc. Same with if I'm doing some very small bore pipe and I want to do a center. It was just something that I thought I could include on there. Same with a thickness size. So I've got 2, 3, I think that's a 6, 8, 6, 7, 8, and then I've put a square drive on the end there. As well on here is, I like the idea to do a 45 degree. So if I'm selecting up on a workpiece, I can have a 45 degree on here, and I can measure, mark, scribe on that point there. As I say, it's all made out of stainless steel. It's 2mm thick. I might change these grip to make these thicker, to have a bit more of a plinth on here. But for now it's quite nice. It fits in a pocket really snug. Typical work trousers have a slot this wide for something like a rule. and it's nice and easy to grab out of the pocket. So this is the bare bones. We're going to have one grip side here, the other one on there. We're going to have some riveting done on here. Squash those through on the small little arbor press that we have, and that's kind of it. It's not complicated. It's a nice, easy, straightforward tool, and I think if you showed up, you know, this on your job site, etc., whatever you're doing, you know, it doesn't look like a toy. So, right, let's stop talking and start making. Over on the drill press now, we've got a 6mm countersink bit on here, and we've set the depth to just go below it on there, so that should be around the depth. It's just take a little bit of time to do. If you had I've got a milling machine, but I figure that most people haven't got a milling machine, so I'm going to do it on the pillar drill here. 6mm size, and I've got the rivet next to me just to keep checking it. So we've got both of these now countersunk in, looking nice. What you should be able to do is just run your fingernail over there like that, and you'll know that they're flush. So these, I would say, I think they're a little bit, need a bit more. Like this, you see? Now, typically with this size of rivet, you would use something that's called a Vanmar, which looks something like this. But I don't have one of those anymore because I got rid of all of mine because I don't do this type of thing. You can use the small little independent ones. I don't know what they're called. They're like a rivet countersink, which is, they can do more harm than good sometimes. And I've only got this cheap Chinesium countersink here, which does do the job, but it does leave a bit more of an overlap there, which you typically wouldn't see in assembled operations in something like aerospace or automotive. Not that you really have rivets in automotive. So let's keep going with this, and we're going to have just a little bit more of a ring, but it's okay. So we've now got those down. As I say, there is a little bit of a gap around there, but they are nice and flush. Okay, so we have driven out both of the grips, and what I've done, because these aren't quite long enough, these rivets, so on one side I've countersunk them not quite the same depth as the other side. So I've got those ones that are nice and flush, and then I've got these ones on the top that I am going to squash down. Now this isn't an ideal setup, and it's not the best for doing this. Really you'd use a fly press or something like that, but this is what I've got, and it does a job. So now I need to move the camera and put a little bit more force on it, because that's nowhere near enough. Okay, well, I am now out of breath. So they're not quite big enough on there, and they're not that proud. So we're going to do it with a punch and just finish that up. Okay, so we have our punches here, and we're just going to select an appropriate size. Yep, that ought to do that. So they're not perfect. I'm going to do a few more off camera, but that's the countersunk side. Hope you can see that. And then that is the not countersunk side. Well, the tail side, if that's what you want to call it. So we'll just do a few more on there and then get that done. Okay, let's take a look at what we've got and what we've done. So, good side, acceptable side. These rivets here, I'm hoping that you can see that okay. Focus. We've got the tops done in here. The heads aren't too bad. We've used a punch, as you can see. And we've got this bit of a laser edge that we've got to do and clean up these sides now. So we've got this burr on here, it doesn't affect the use. The cuts are straight, there's no kerf marks, kerf lines. There is a bit of spatter on the holes on here, but nothing too critical. It's not pretty, not good enough to, I don't know, try and market and sell. These are just for me, close friends and other makers. So let's just go over with some Scotch-Brite and go from there. So we're pretty much finished with this now, really. There's not a lot of assembly work to be done on it. Those of you who are watching, I hope you like the design and love to hear your feedback. Got some lead-ins here that we need to change on future ones. These were meant to be square holes. A laser should be able to do that pretty easy. I'm going to just grab a little drill bit here. And there's a little bit of a splatter burr on here, so just lightly try and knock that off. Let's get a proper engineering square and test this. Okay, engineer square, anchor square. Let's see here, so make sure everything's clean. I have to use a dirty rag because the white rag couldn't be seen on the video. That's a good excuse, right? Okay. And that is, I can't hold it that well. Hold on. You can feel the clunk. There is no light coming through there at all. Pretty pleased with that. Yeah. It's catching on the edge. You can just hear it scrape. I don't know if you can hear that. It's going to be close enough for a wood butcher. Okay, let's do a little bit of a close-up now, so you can see just how not quite perfect the rivets are here. And the edge is cleaned up a little bit, quite nice. This is the fibre edge that you're going to have. Focus. On here, nice and straight lines. Sandwiched in. These ones are a little bit better. And these are the little stains that we've got on here. With the Scotch-Brite, we've managed to take that off, but this is why these parts were rejected. And I got them free. So guys, I hope you like that. I hope you like the little square. I've got 2 now, and I've got another 18 to make. So I'm going to test these out in the field. I've got some guys who are joiners, some mates who are joiners, got some mates who are tilers. I'm an engineer myself, and I know some more sheet metal workers to go and give them a try. So thank you so much for watching, and if you don't mind, give us a like and a subscribe to see more inventions and techniques and designs for the channel. So, and if you want to see behind the scenes and more content, check me out on Instagram, which is anchordesigns_GB. Thanks very much, and see you next time.